Hi there, and welcome back. What we're going to do in this video is find the exact value of cosine of x minus y, where x and y are angles, given that cosine of x is negative 2/3 and cosine of y is 3/5, where x terminates in quadrant 2 and y terminates in quadrant 1. So the first thing we need to do is expand the expression for cosine of x minus y so we know which trig functions of x and y that we need the values of. So remember, by identity, cosine of x minus y is equal to cosine x times cosine y plus sine of x times sine of y. And now what we need to do is find the values of sine x and sine y because we were given the values of cosine x and cosine y. So I'm going to go ahead and fill those in here. This is negative 2/3 times 3/5 plus some value times some value. So how do we find those values? Well, there's two ways. We could use triangles or we could use identities. In this video, we'll use identities. So we know cosine x, we need to know the value of sine x. The identity that links them together is the Pythagorean identity, sine squared x plus cosine squared x equals 1. So we know cosine x is negative 2/3, so that means this is plus negative 2/3 squared equals 1. Sine squared x plus negative 2/3 squared equals 1. And we know that negative 2/3 squared is 4/9. So I'm going to subtract that from both sides, and that's going to give us sine squared x equals 5/9, which means sine of x is equal to plus or minus the square root of 5/9, which is plus or minus square root 5 over square root 9, which is 3. So now we have to decide which is it going to be, the plus or the minus. Well, since x terminates in quadrant 2, the value of sine of x is going to be positive because sine is positive in the second quadrant. So we're going to use sine of x equals square root 5 over 3. So I'm going to go ahead and substitute that into the expression right here. So we have square root 5 over 3. And now for sine of y, we'll do exactly the same thing. We'll use the Pythagorean identity, make our substitution, and see what happens. So we know that sine squared of y plus cosine squared of y is equal to 1. We know cosine y is 3/5. So we have sine squared y plus 3/5 squared equals 1. So 3/5 squared is 9/25. Subtract that from both sides. We have sine squared y equals 16/25, and then apply the square root principle. Sine y equals plus or minus, now the square root of 16/25 is 4/5. And again, since y terminates in quadrant 1, we know the value of sine y is positive. So that means we're going to use sine y equals 4/5. So that gets substituted here too. Now what we'll do, I'm going to draw a little arrow here, and we're going to simplify this expression a little better here. So negative 2/3 times 3/5. Now ordinarily we would cancel the 3 since it's a common factor between numerator and denominator. But seeing into the future a bit, we're going to have two expressions with the same denominator, 15, if we just simply multiply them. So we're just going to write that as negative 6/15. And then plus, and then looking back up here, we have square root 5/3 times 4/5. That is 4 times square root 5/15. And if we want to write that as one single fraction, we can write this as negative 6 plus 4 square root 5 all over 15. And that is the exact value of cosine of x minus y.